Welcome, dear learner. We are discussing about the arrays and pointer in a C. In a previous lecture, we discussed about what is array. Friends, in this lecture, we have to see what is pointer. So, introduction to the pointer. If we consider the computer memory, then the computer memory is a sequential collection of a storage cell. Each cell commonly known as a byte. We know that one byte is of a 8 bit and each byte have unique address starting from 0 and the last address is depend on memory size. If we consider the 64 kilobyte memory, computer system having 64 kilobyte memory, then the last address of the memory cell is a 65,535. So memory cell, okay, each cell is of a 1 byte. Each memory cell is also known as a register. Each memory cell have a unique address. It is a starting from 0 so that the address of a first memory cell is a 0, second memory cell is 1, up to so on, and last memory cell address of a last memory cell is 65,535. Whenever we declare a variable, we know that while writing the programs we require number of variables. Okay, then the system allocates somewhere in a memory an appropriate location to hold the value of that variable. Since every byte has a unique address number, this location will have its own address. Value of a variable is stored in particular location and that location have unique address. Consider the following statement: integer, okay, so this is the data type. Quantity, this is the name of the variable, is equal to 179. 179 is a value of a variable. In this statement, instruct the system to find a location for the integer variable quantity and put the value 179 quantity variable in that location. Let us assume that the system has chosen the address of a location is 5000 for quantity. Okay, so quantity, this is the variable, then 179 is value and address is 5000. So the quantity is the name of the variable, okay, and value of that variable is 179 and this 179 is stored in a unique address that is 5000. During the execution of a program, the system always associate the name quantity with the address 5000. We may have accessed the value 179 by using their name quantity or address. So we can access the value 179 by using name, that is a quantity, and by using address, that is a 5000. Since memory address are simply number, they can be assigned to some variables that can be stored in a memory like any other variable. So what is this pointer? Pointer is the variable that hold the memory address and called pointer variable. Variable that hold memory address. A pointer variable is therefore nothing but variable that contain an address, which is a location of another variable in a memory. Pointer are built on the three underlying concept as illustrated below. First is a pointer constant. Second is a pointer variable. And third is a pointer value. By using these three, we can build the pointer. We have to see one by one. First is a what is pointer constant. Memory address within a computer are referred to as a pointer constant. Memory address cannot be changed. We cannot be change them. We can only use them to store the data value. In previous case, 5000 is a address and 179 is a value which is stored in that address. They are like house number. Then a pointer value, we cannot save the value of a memory address directly. We can only obtain the value through the variable stored there using address operator. Okay, we use and as a address operator. The value thus obtained is known as a pointer value. The pointer value, that is the address of a variable, may change from one run of a program to another. Then what is a pointer variable? Once we have a pointer value, it can store into another variable. The variable that contain a pointer value is called pointer variable. Okay. Now, now what is this pointer? A pointer is a variable that represent address of a particular data item. Variable that represent address of a particular data atom. So fundamentals of a pointer. Suppose V is a variable that represents some particular data item. V is a variable. The compiler automatically assign the memory cell for this data item. Okay, that is at a particular address, the data item or particular value is a save and compiler automatically assign the memory cell. The data atom can be accessed if one known location of first memory cell. There are two ways to write address or location. First is use of address operator. We can use address operator to write the address, okay, or location. We can use pointer. The address of V's, that is variables, memory location can be determined by expression and V and means address. V is a variable where add is a unary operator called address operator. Let us assign address of V to another variable PV. So PV is equal to and V. It represents and v means address of a variable v which is assigned as a pv. Okay, address of v and value of a v. The data item represented by v can be assessed by expression asterisk pv. Okay, star means asterisk, where the unary operator called in a directional operator that operate on a pointer variable. Asterisk PV and V represent same data atom. Okay, when we have to assign particular pointer, then we use asterisk. Okay, if we write PV is equal to at the rate and V, that is the address of a V is assigned as a PV, and V is equal to asterisk PV, then U and V both represent same value. The address operator must act upon operand that are associated with unique address such as ordinary variable or a single array element. The directional operator can act upon operand that are pointers. Thus, pointer variable can be assigned the address of a ordinary variable. Therefore, PV it is equal to address of a variable v. Pointer declaration. When pointer variable are defined, the variable name must be preceded by asterisk. Pointer declaration can be written as data type. Okay, we can use a different data type. Okay, asterisk p, that is pt variable. Okay, pointer variable. Data type may be integer, it may be floats, it may be characters. Okay, and the asterisk sign represent that variable ptvr is a pointer. Example, character. Character is a data type. Asterisk sign p underscore character 1. Now, p underscore character 1 is the name of a variable, and this name of a variable is considered as a pointer, or we can say that mean p underscore character 1 is a pointer type character. Okay, then the pointer and one dimensional array. When an array is declared, the compiler allocates the base address and sufficient amount of storage to contain all the elements of array in a contiguous memory location. We know that the array is the collection of a same number, same types of elements. Okay, and we can use pointer and one dimensional array. The location of first element is a base address. The size of the data type which the pointer variable refer to is depend on the data. For example, if the pointer variable points the integer data type, then it access 2 bytes in a memory. Here we use 2 bytes of a memory. Assuming that an integer occupy 2 bytes, a, a pointer when incremented always points to a location after skipping the number of bytes required for the data points uh, pointed to by it. For example, if we declare an array as follow: static integer, okay, static integer, it indicates that it consists of a positive integer and a negative integer. A is A is a name of the array, 5 is the size of array, and the element in the arrays are 1, 2, 3, 4, 5. If base address of A is 1000, okay, and assume that each integer required 2 byte, the 5 element will be stored as follow. Okay, the element, the array A0, it indicates that the first element, okay, and the value of the first element is 1 and address is 1000. It is of a 2 byte, and therefore the second element is A1 and the value is 2. Address is 1002. Similarly, third element is A2, value is 3 and address is 1004. Fourth element is A3, value is 4 and address is 1006. Then fifth element is A4, value is 5 and address is A008. We know that each memory cell consists of 1 byte. Okay, 1 byte. But here we use a 2 byte, and therefore address of a first element is 1000 and address of a second element is 1002. So it is incremented by 2. The array A is defined as a constant pointing the first element A0, and therefore the value of A is 1000. The location of A0 is stored. So A is equal to address of first element of array. Okay, and first element is A0, it is equal to 1000. If we declare P as an integer point, then P is equal to A. This is equal to P is equal to address of first element of a array. Now we can assess every value of x using its increment to move from one element to another. P is equal to address of first element, it is equal to 1000. When it is incremented by 1, that is P plus 1, okay, we get address of a second element, okay, and it is 1002. When P is incremented by 2, then P plus 2, its address of a second element, it is equal to 1004. P plus 3, that is it is incremented by 3. Then address of a third element of a array, it is equal to 1006. P is incremented by 4. Then address of a fourth element of an array, it is equal to 1008. P is equal to address of a first element A0, it is equal to 1000, and so that it is incremented by 1, 2, 3 and okay. Thus, address of A3 is equal to base address plus 3 scale factor of integer. So base address is a 1000 into 3, uh, 1000 plus 3 into 2. Why 2? Because size is a 2 byte. Okay. So it is 1006. 3 plus 3 gives value of third element of array. Thus we can use pointer to access array. Such pointer accessing is faster than array indexing. Now we have to see what are the different applications of a pointer. Pointers can be used to simulate passing parameter by reference. Hence, arguments can be modified. It provides alternative method to access array element. It can be used for passing array and string to function. Pointer are efficient for handling complex data like list, trees, graph, etc. Pointer is in a dynamic memory allocations. Dynamic memory allocation means memory allocating a memory storage space at a runtime. That is, we can change the value, okay, in a particular memory location. It can be changed dynamically, okay. That is memory storage space at a runtime. We can allocate and deallocate memory whenever we require. So in this lecture, we discuss introduction to the pointer, then the what are the memory cells, then what is the pointer, then arrays and pointer, basically one dimensional array and pointer, and the application of a